In this Galaxy screencast, I'd like to show you some new tools for quality control of short-read sequencing data that have recently been added to the main Galaxy site. They're only available on test at this moment while I'm making the screencast, so that's where we are temporarily. I've downloaded some data from the 1000 Genomes project to use for this demonstration, and I'll show you how I got that data at the end of the screencast. But let's start off by going to the Next-Gen Sequencing QC and Manipulation menu and starting some of the jobs. I'm just going to kick off a whole lot of QC and metrics jobs, and we'll let them run. Like all Galaxy tools, when you click on the GC bias metrics tool, for example, you'll see the option to run one file, which is the one that I have in my history. If there were more BAM files or SAM files, they'd appear here. I'm going to leave all of the defaults. There are lots of things you can change, but for this demonstration, let's just click Execute and get the job going. I'm also going to run the Fast QC tool from Babraham Bioinformatics. Again, I'm just going to accept all of the options. I'll also run the index statistics tool from Picard, which will show us where the mapped reads have landed on the contigs from the reference. Let's run alignment summary metrics. Again, I'm just going to accept all of these defaults, and we're just going to run it on the one BAM file I have in this history. Let's do the library complexity measures from Picard. Let's run insertion size metrics. It'll work for this tool because this is paired data, and we click Execute. And the tool that we can't run because this is not hybrid selection data is the SAM-BAM hybrid selection metrics. There are also a bunch of cleaning and repair tools which are also very important, but I'm not going to demonstrate those at the moment. So you can see in my history that one of the jobs is finished, the BAM index stats. Let's see what we get. I click on the eye icon, and remember, this data advertises itself as just being chromosome 20 data from the 1000 Genomes project. It's one of the smaller files. It's only, let's see, it's only 235 megabytes of data. So it's a pretty fair size file, but it's only one chromosome. And you'll notice that the Picard tool has correctly shown us that we only have aligned reads on the chromosome 20 contig. Everything else is empty. So that's the nature of that report. A couple of the other reports have finished. Let's just look at them. Remember, when you're running Galaxy, running jobs are yellow, and as soon as they finish, they go green. Let's look at the insertion size metrics. Remember, I said this is paired data. So this is a little thumbnail of the print quality PDF. If you click here, you'll download a decent sized PDF. Just a couple of words about all of the Picard tools. They're really easy to run on the command line. So why would you run them in Galaxy? Well, mainly because the outputs are so nicely organized for you here. They're just much easier to deal with. They're stored permanently in a history for me, so I can come back and see this. It's persistent. It'll be here in a year when I come back to look at this particular history. You'll notice I've named this history just by clicking in the name box and typing Picard screencast. So all of these advantages come to me when I use the Picard tools through Galaxy, and of course they're nicely integrated with all the other Galaxy tools. The library complexity measures, these are going to start to look familiar to you as we go through them. Clearly, this is just the output from Picard. You'll notice there's lots of errors, but the Galaxy tool still worked. It just put the errors there for you, and if you really want to look at them all, you can click on the log file and see them. In fact, there are thousands of them. They've been cut off by the tool because there's no point in displaying them all. The short-read GC bias metrics, a very nice report that you get from Picard. Again, if you click here, you'll get a print quality PDF download of the GC bias plot, and all of the Picard outputs are here if you need any of them for other purposes. Okay, the final tool that I just want to show you the output from is the Fast QC tool. It's not a Picard tool. This is from Babraham. If you look down the bottom, you'll see the attribution and where to go to the Fast QC website. But essentially, the Fast QC tool will run on BAM or SAM files or FastQ data. I've run it on this BAM file, and you get a summary at the beginning which has green ticks for things that were detected as being within expectation. But there's a couple of these reports that show an orange exclamation mark. You'll sometimes see a red mark, which indicates things are very bad. And FastQC seems to think that the per-base sequence quality report is worth looking at, and indeed it is. You can see that there's a drop-off in quality for the first few bases of each read, and then the last bases of each read. There's a substantial decline in quality. That's not unexpected, but it's nicely highlighted in this beautiful report. And the second thing that's been highlighted is the K-mer content report, and we go down and have a look, and indeed it looks a little puzzling. It's a very interesting looking piece of biology that probably drove this particular pattern of K-mers at various positions in the read. But rather than focusing on the actual quality of the 1,000 genomes data, what I really want you to take away from this screencast is the knowledge that you can go to Galaxy, you can download 1,000 genomes data, and the way that I got this particular one, of course, was by going to the 1,000 genomes website at FTP trace NCBI NIH.gov, navigating to one of these directories and finding a reasonable sized file, in this case the chromosome 20 file. I've left clicked, I can copy the link address, and then I'm going to go back into Galaxy. I can go up into the Galaxy Get Data tool, choose Upload File from your computer. It's a little misnamed. In this case, I'm simply going to paste that FTP URL into the URL text box. I'll tell Galaxy this is a BAM file because I know it is, and I'll tell Galaxy that it's aligned to GRCH build 37 because it probably is. I click Execute, and Galaxy will now go away and get the data from the NCBI FTP site and put it in your history. When this job turns green, I'll have another copy of this data set. So in summary, a bunch of new quality control and metrics tools from the Picard project are now available in Galaxy, and given the importance of quality control in any kind of biological analysis, particularly with a complicated technology like short-read sequencing, I'm sure you'll be able to find good uses for these tools for your data inside Galaxy.